All right, so we're starting 3-6, example 1. Use properties of operations to write equivalent expressions and then try it. And I will say, starting off this section, if you do not study the words that go with the skill, you will find this very challenging. It's not the easiest thing without studying those words. However, I know that studying the terms for the properties of operations is going to be critical. So please, if you do nothing else, set up some flashcards. There are 3 properties that we're going to be talking about. There is the commutative property of addition and multiplication. There is the associative property of addition and multiplication. And there is the distributive property for addition and subtraction. So 3 different properties, each of them controlling 2 different operations. That's a total of 6 different concepts that you're expected to know and be able to work with. So please, please, please set up some flashcards. If I can, I will try some kind of technical flashcards that maybe you can download or use in some creative way. But it's still a really good idea for you to do your own set as well. Vocabulary in this section is going to be critical. Let's see what they got for us. All right, I'll stop it there because this is outside of knowing what those words are. And again, I know it's a lot, but once you know that the associative property of multiplication to regroup, we're going to take 3 times, well, here's the original, right? And then they did the distributive property first. They took this 3 and they multiplied it by everything inside the set of parentheses. So 3 times 4x is right there. And then they took that same 3 and they multiplied it by 1, and that's right there. And then finally notice that there was a subtraction sign in between them, so they kept the subtraction sign. So first they did this distributive property. So they took the 3 and multiplied it by everything inside and rewrote it to look like that. All right, so here the dot is a little low, but that dot means multiply, right? So they're doing 3 times 4. 3 times 4 is 12x, and then minus 3 times 1. So if you think of that last example where we took the 3 that was outside and we multiplied it by everything inside, well, the reverse is asking, what would I have had to divide by in order to get that kind of concept? So here, in this example, one of the reasons that we did the ladder method early on was for this exact reason. So I'm going to remind you first, this is very simple, a very easy ladder method problem. But if I wanted to factor the 2 and the 4 using that ladder method we talked about, I noticed that 2 goes into both of them. So 2 divided by 2 is 1. That's a 1. That's a 1. That's the worst looking 1 in the history of ones. And then 4 divided by 2 is 2, right? Now I have a 1 and a 2, and I factored a 2 out. Well, the reason this ladder method is so effective here is because the greatest common factor of those two things is the factor that goes in front of a set of parentheses. Now, the two things that have to be in the parentheses, for right now, I'm just going to draw in blanks. But those two numbers are at the bottom of our ladder. So a 1 and a 2. Then the only other thing I have to remember is if I have to multiply 2 times something to get 2x, and there's a 1 here, I just need an x to go with that 1. So 2 times 1x gives me 2x, and 2 times 2 gives me 4. So when you're talking about the reverse of the distributive property, you're really talking about factoring. And one of the reasons we spent a lot of time on doing that ladder method is so that this portion will be easier for you. All right? All right, so, here they factored the 2 out, just like we talked about. Here they distributed the 3, everything in. So factoring is kind of the reverse of distribution, and distribution is the reverse of factoring. They kind of go back and forth. One's multiplying, one is, in a sense, dividing. All right, so this one here, same thing. We're gonna do our ladder method. This is great. This is whatever, and it's not wrong. But again, we put the time and effort into teaching the ladder method because of that last step. So again, I'm going to factor a 3 and a 9. I'm going to find the greatest common factor of 3 and 9. I notice that 3 goes into both of them. 3 divided by 3 is 1. 9 divided by 3 is 3. So that tells me that the greatest common factor is 3. So that means I'm going to factor a 3 out of this expression. That goes on the outside of a set of parentheses. And especially in the beginning, I like to just put in these blanks so I know what I'm doing here. Now, what has to go inside? Well, I can bring over my subtraction sign too. There's a number and a variable here and a number here. Well, here they are. I have 1 and then the y here and then the 3. So that if I wanted to check my work, right? If I wanted to say, hey, is this correct? What would I get if I distributed this 3 to everything inside? 3 times 1y gives me 3y, so that part is correct. 3 times 3 gives me 9, so that part is correct, and I still have my subtraction sign. All right, so that is factoring, or write an expression that is equivalent to that. We could just factor a 3 out, and this expression is equivalent to the original. It's equal to it. All right. All right. So the questions that go with this are 11 to 20, 25, and 28. I will write them so you can copy them so you know what you're doing. All right, so here's the questions that we're doing. Questions 11 to 20, number 25, and number 28. Remember to ask questions, get your answers, and move on. Good luck.